Time for the final major part of the PCB design, which is to turn the rat's nest into actual traces. We have to decide whether we want the traces which connect components to be on the top or bottom layer. And we have to really hope that our layout is good enough where we don't have to move any components around. And kind of go back to the drawing board. I have some confidence because this is a pretty straightforward, although high density, very repetitive layout, and I think I've done a nice job of getting the pieces to minimize the rat's nest, so hopefully we can do it. You want to make sure that you don't have a strange setting for your tracks or vias. 1/4 millimeter track size and 0.8, 0.4 millimeter vias. Vias are the connections between copper planes, top and bottom, is a pretty conservative, decent setting. Any number considerably smaller than this, you need to check with the manufacturer and make sure that it's not too small a feature size to be made. The routing tool is this one, not to be confused with a multiple part tool, which is just for drawing polygons. But this is actually for routing. And we'll start with the ground connections, which we'll put on the back plane, and then try to put as much else on the front plane as we can. So the back plane, selected here, will show up as green. And basically go over and start on something we know is ground, which is going to be one of those first pins. And you'll see that it has highlighted all of the ground connections on the board that can be gotten to with single trace here. So let's start connecting. You can see as I move around is trying to guess where I should make connections. Let me start by doing the easy ones. Every time it is complete, you will notice that the rat's nest disappears because it's been replaced with actual traces. Let's zoom in and look at this a little bit more detail. We'll see that there are now green lines between the different components where I've clicked on them, and of course you go back and delete ones if you make a mistake. All right. Nowhere else obvious to get to from this point, so we'll hit the escape. That leaves all the remaining tracks I've done in place, and continue. Now it can be useful at this point in time to turn off some of these other layers which are creating just a lot of stuff to look at. Some of these outlines, some of this extra writing, just enough to kind of be able to still see what's going on. All right, back to routing. Notice how all my effort into lining up these resistors has really worked out great, because I can just go and fill them in pretty easily now. Looks like now we're going to be wiring up the bottom side of the pots. Alright, so we still need to get over to this region with grounds. Maybe we'll go from this near neighbor here. Now, here's an important thing. The C4 capacitor was a filtering capacitor for IC2, which is the 4017 decade counter. So we want to make sure that that ground is in close proximity and connected to the ground, so it does the best job with no parasitic capacitance is picked up by long run lengths. Long wires do have some capacitance. We want to minimize that, so we're nearby. We go right to the two grounds here. Similarly, we want to make sure that that ground is also close to the smaller C5 10 nanofarad capacitor for fast filtering. All right, where else do we have to go? So again, I just kind of click on it, look where I have to go. Don't want to start from here, I want to start from this one. Going over to the audio jack. Anyone else left? Looks like we have satisfied all the ground connections. Again, green is for the backplane. And all those grounds are in the center, of course, of our pins. Let's move to the front surface and look at attaching some of the power. We're going to start with the plus 12 because we know there's not much minus 12 in use in the circuit, so we'll go look at the plus 12 first because it'll be more complex. Note the color change to red because we're on the front surface. The colors can be changed, so if you have trouble seeing the difference between red and green, don't find high enough contrast or not, I encourage you to explore some of the different preferences. This guy's going to make a pretty circuitous trip, it looks over to get to C5. But there it looks like we have gotten rid of them. So you can understand the name of the game is to get rid of as many, eventually you have to get rid of all of the rat's nests, make sure they're all gone and replaced with actual traces. Let's keep going. What should we do next? Seems to make sense to deal with these long run lines that go to the potentiometers. So each of these are the outputs of the sequencer that are going into the square connector. So they all should end up eventually check him out again. Let's go do the middle parts, etc. I'm going to pause the video and return when I'm done. So after some clicking, you'll find you have significantly reduced the amount of rat's nest and significantly increased the number of green and especially red traces. But that you're not done yet. There's still lots of white traces indicating rat's nests that can't be completed, and even your best attempts to do so will often be met with failure because there simply is no route that the software can find to get where you want to go that doesn't cross other wires. So, since you can't cross wires, you have to go back to the other side. We go back to the rear side of the board. So we'll be working in green again. And now we're going to continue and see if we can get rid of more rat's nest wires, the temporary connections, by putting in green traces on the back side of the board. There will still be some places where you can't, and we'll deal with those by making small holes through the board called vias shortly. Let's get what we can do done with the rear traces. And I'll come back in a moment after I've further reduced the rat's nest using rear side traces. You should be left with only traces that you cannot manage to complete using either the back copper or front copper layers on the PCB. Useful thing to do at this point is to get rid of dangling traces. I'm going to zoom way in on one chunk of the board here. I'll show you a couple of neat features when you zoom in. So you can see the absolute detail, how the pads are going to connect to each other. You'll notice that each connection is labeled as a net, and we'll pretty much tell you where it goes if you look at the writing, which is only viewable when you zoom way in. There is a high contrast mode. And outline viewing mode, which can make it easier to see things sometimes. As we look around, though, we will find there are some things that don't really make sense. There are some tracks which were drawn, like here around LED 15 next to resistor 15, diode 25 and 35. Where we have a net. Now this is absolutely fine. The red front copper trace is slipping past, of course, the bottom one, which is green, so that's fine. But as we look here, there's a break in the wire, right? And then there's a rat's nest that continues from this position. So this is an attempt where we got a little bit too crazy clicking away, and we tried to make KiCad do something which it didn't want to do, which was you can't connect this red wire to this one or any others up here because we'd have to go through this wire, which is a different connection. So to clean things up a little bit, let's try Edit, Clean Up Tracks and Vias. It can be a little bit dangerous at times, but usually it helps remove some of the mess. It's good. Delete the track segments connecting different nets. So a different net would be a wire, which is holding a different signal on it. Get rid of redundant vias, overlapping segments, and most importantly, dingling tracks like this one. There. So our board is actually now much cleaned up. It does look like there's more rat's nest, but that is because all the rat nests are largely complete segments again. And we're going to have to actually burrow under or underneath other tracks to get the job done here. So that is our next job, and that is called making a via, which is a pass-through from the top to the bottom of the board. And if you look at the Thomas Henry VCO board that I designed for you, you'll notice it has several vias on it, which appear as just very tiny little dots, way too small to stick a normal through-hole component through. Those holes are transmissions top to bottom of signals. So let's try to pick a couple vias here. Here actually looks like to me a wire which, after we've cleaned things up, maybe we can complete now. So let's take the low-hanging fruit while we can. There's only one crossing from pin 9 to pin 9 here, and the jumper. Let's try to do that with a top layer. Beautiful. Got rid of one. So we might be able, now that we've cleaned up some of the messes, find a few more that we're able to actually to do. So you can see this one still can't complete. Can't find a way to draw its way down. But maybe some of these others we can manage to find a way. If we see only one color crossing, it's quite possible that we can use the opposite color to make it there. Nope, not able on this one. There, got rid of one. Nope. Can't make it. Try the other layer. Got it. If you can't get in one color, try the other. And once this is done, we'll want to go back, clean up traces again, and see where we are. The idea is to keep the final desperation stage, which is adding vias or pass-throughs, to an absolute minimum. Actually, you'll be down to traces which you cannot complete. Let's look at this one from the center of pot 11 to the anode side of diode 31. So we have to transverse both a green and a red levels to get there, which means we can't just go on a single color with a two-layer board. So I'm going to grab a via, which is this circular tool, and think about running the trace out in green to this point over the red line, and then from red we'll go across over these green ones down to that pad. So I'll stick my via there, Go back to the routing tool, put it on the bottom green color. There can be a little trickiness. Sometimes you're better off running the trace first. And then switching to the via. And then running. Off the routing tool. Complete the trace. And there we go. That rat's nest line is gone. You have to repeat that for the remaining handful of traces you've not been able to cure any other way. This means a hole will be put in the board at this location, although a very small one. The Baby 8 synthesizer sequencer is done. I put in lots of vias to make sure that I could route it. The rat's nest is gone. Double click that. See none of those white lines popping up anymore. Do an error check with the ladybug symbol. Check also for errors on your track. And there's no unconnected items. The only problem comes up is the footprints on J4 and J5, which is where we'll be connecting. Jumper wires. I know I had the footprints overlap because I set them a very specific amount apart, so I'm not concerned about that. I've redrawn my outline, left a little bit extra space on the edges so nothing gets too close. Again, we'll be mounting it with the J1, J2, and J3, 3.5mm mono jacks. Power will be coming in on the back side. The pots we'll be using for the sequencer are cheaper pots. They don't bolt into the case, so I've added some mounting holes. Adding mounting holes and other features can be done by placing footprints directly on the PCB. So for instance, I found some mounting holes which have a pad or exposed copper surface on the top, and then I flipped them over to put them on the bottom and inserted those, did a little rewiring of wires to make sure they were clear around. So a couple mounting holes and 3 jacks for mounting. Let's take one look at the 3D viewer. Looks great. Definitely spend some time looking it over, thinking about what's going on, making sure everything makes sense. You can see my mounting holes now in the back there. Looks good. We're going to save it. And probably nice to make some pictures of it for your record. Normally we would have to export a whole bunch of files. I will export a bill of materials file. Which will be useful. But Osh Park can actually take our designs as they are. Let's see how it uploads to Osh Park. That's a great test because the manufacturer also does some checking. Sequencer. Look at that, ready for manufacture. Two-layer board of 2.4 by 4.28 inches. Makes sense to double check those numbers very closely. This is what the bottom of the board looks like. This is the top of the board, and at this point we'd be able to fab 3 boards, small quantity, for $50 total. All it needs is a credit card. In the next videos we'll be designing the ADSR envelope generator circuit from scratch this time, though, starting with the circuit diagram.